Hi, Math 2 Enhanced. This is page 17 of our packet. Hi, Math 2E. This is page 17 of our packet, and it's an introduction to graphing logarithmic functions. But before we look at that, let's look at a function you graphed last year. Let's look at an exponential function, y equals 2 to the x. So let's make this table for this y equals 2 to the x. When I substitute a negative 1 in for x, I would get y equals 2 to the negative 1, and we know that that's 1/2. When I substitute a 0 in, I get 2 to the 0, and we know that that's 1. When I substitute in a 1, I would get a 2, 4, and an 8. Why don't you take a moment and graph all 5 of those points? So I have my 5 points on the graph, and now we're going to connect them. Remember that this is an exponential function, and if you remember from last year, you have an asymptote. A horizontal asymptote, this is not going to cross, and it's the x-axis. And we draw it, getting really close to the x-axis, but not crossing it. So our horizontal asymptote is the x-axis, and we can also say that that is the line y equals 0. So now let's turn our attention to the inverse of that function. If I flip-flop my x and y, I now get x equals 2 to the y, and this would be the inverse of what I've graphed in blue. So let's take a look at what we'd get if we substitute in our values again. So when I put a negative 1 in for y, I would get that x equals 2 to the negative 1. We know that that's 1/2. We substitute a 0, we get 2 to the 0, we know that's 1. 2 to the first would be 2, 2 squared would be 4, and 2 cubed would be 8. So take a moment and graph those xy coordinates on your graph. So now we're going to connect these points, but the difference is this graph now is slowly growing upwards, very slowly, and it comes really close to our y-axis but doesn't cross. So now we have a vertical asymptote. Our vertical asymptote is the y-axis, and that is the line x equals 0. So we talked just a moment ago about how these are inverses of each other, and briefly earlier this year we discussed that inverse functions are reflections in the line y equals x. The line y equals x is the diagonal line that goes through the origin, and negative 1, negative 1, negative 2, negative 2, negative 3, negative 2, 6, 6 up here, 7, 7 up here, 8, 8 if I could go on. So it's the diagonal line going through the origin, and my red and blue graphs would be reflections across this green line. Let's label it y equals x. So now let's go down our page and talk about this inverse function. This function we graphed in red right here, this 2y equals x. We've learned that we can change our exponential functions into logarithms by using our backward Z. Our logarithm base 2 of x is equal to y, because our logarithm is equal to an exponent. And so this log base 2 of x equals y is the inverse to the blue graph that you see. When I want to graph a log graph, the red graph I have up on my graph is the graph of a log. When I want to graph a log, I make a table, much like we've done for other functions. This table consists of numbers I pick based on the base. So the values I use for my x will always be 1, and then whatever my base is, and 1 over my base. And you'll see this better on the next page, but when I use those numbers, my y values are 0, 1, and negative 1. That's when my graph is not shifted. So let's go back up to my red graph and take a look at this. So let's say I wanted to graph and I didn't have that pre-made table. And instead, I looked at my base being 2. So based on that, my x values I was going to use are 1, 2, and 1 over 2. Let's consider what my y values would have to be. Well, for 1 to equal 2 to some value, I know that my exponent would have to be 0. For 2, I know that my exponent would have to be 1. For 1/2, I know that my exponent would have to be -1. You'll notice, let me grab a highlighter. You'll notice that these values 1, 0, 1, 0, 2, 1, 2, 1, and then this 1/2 -1, 1/2 -1 were part of the 5 points I graphed to graph the red graph. These are my 3 main points. Once I graph those, I can graph my graph of my logarithm. So let's talk about a couple other things, and then we'll flip to the back page and try this. So let's talk about our domain. So as I look at my red graph, we're considering the red graph right now, which is our log graph. It's our y equals log base 2 of x graph there, the red one. My domain, if you notice, my red graph does not cross the x-axis. It doesn't have negative values of x. So my domain starts when x is 0 and goes to infinity on the x-axis. Notice I do not have a bracket at 0. It never touches the x-axis. It just gets really, really close to it. What's my range? Well, you'll notice that my red arrows are growing upwards really slowly and growing downwards actually very quickly. So my range is all real numbers. All the y values are on my red graph. My x-intercept in this case occurred at 1, 0. I did not have a y-intercept because it didn't cross the y-axis. And I do have an asymptote. That asymptote is x equals 0. That's a vertical asymptote. That is also the y-axis. When we go to graph, we have all the same things to consider that we've had to consider so far. Our horizontal shift will be inside the parentheses, and this is where you have to think the opposite of what you see. So when my h is positive, it really looks negative, but this is when I shift to the right. When my h is negative, it appears positive inside the parentheses, and this is when we shift left, and we're doing the opposite of what we see. The A tells us about, the A in front tells us about our, first of all, it's negative, then this would be a reflection. It would reflect over the x-axis. If the A is greater than 1, it's a vertical stretch. If our A is in between 0 and 1, it's a vertical compression. So K then is my vertical shift, and I'm just going to do what it says. If K is positive, I move up. If K is negative, then I move down. So on this page, the dots that you see on the graph already are the same dots we had on the front side for our graph of y equals log base 2 of x. Those are our 5 points we graphed before. So when we plot a log function, we plot the asymptote and then our ordered pairs. The ordered pairs we like to use for our reference points are 1, 0, because when my x coordinate is 1, my corresponding exponent is 0. 2 to the 0 is 1. And my reference point is whatever my base is, 1, because 2 to the first power would be 2. And then lastly, we also use 1 over our base. In this case, 1 over our base of 2, would be -1, because 2 to the -1 is 1/2. So you'll notice that these 3 points are graphed up here. So now when I shift this +3 is really, h is really a -3. You have to think the opposite. So this is going to move left 3. My asymptote is going to move left 3. My asymptote is no longer going to be the y-axis. And all my points are going to shift over 3. So that means I'm going to take 3 away from my x-coordinate if I'm moving left 3. So now I'm going to be at 1 minus 3, or a -2, 0. And I'm going to be at 2 minus 3, or -1, 1. And I'm going to be at 1/2 minus 3, or -2.5, -1. So let's go plot these. So I'm now at -2, 0. I'm at -1, 1. And I'm at -2.5, -1. And you can see that my graph looks something like this. My new asymptote is here, and my graph is slowly growing to the right. So I've shifted over my log graph from the front side 3 to the left. So let's look here. This one, I'm going to shift my graph up 3. So my y values are going to go up by 3. And inside here, it looks like a -1, but I really have to think the opposite. My h is a +1. So I'm going to shift everything to the right 1. So my asymptote is going to shift to the right 1. Let's draw in my new asymptote. It's no longer the y-axis. It's this line, x equals 1. And so my points also shift over. So my x-coordinate, I'm going to add 1 because I'm shifting to the right 1, so I get 2. And to my y-coordinate, I'm going to add 3 because I'm shifting up 3. So 1, 0 becomes 2, 3. 2 plus 1 would give me 3, and 1 plus 3 would give me 4. So my point 2, 1 now became 3, 4. And my 1/2 plus 1 is 1.5, and my -1 plus 3 is +2. So let's go graph these 3 points. So 2, 3, and 3, 4, and 1.5, -1.5. I'm sorry, is that +2? Couldn't see very well. So now when I graph this, it's very slow growing, and it's going to slide along my vertical asymptote. So before we do the -log2 of x, I want to change this fourth one for this year. If you looked at the filled in packet in the locker, I've changed this. I've taken out the -2 for the a, and we're just doing x minus 1 minus 2. So in this problem, it's still base 2. So my reference points are exactly the same as what they've been. 2 to the 0 is 1. 2 to the first is 2. 2 to the -1 is 1/2. So those are why I have those 3 reference points. So now you'll see that my vertical shift is down 2. So my y values are all going to decrease by 2. And I got to think the opposite. So my change in x is really a +1. I'm moving to the right 1. That includes my asymptote. So let's first mark my asymptote. And now let's find my new points. So I'm going to add 1 to my x-coordinate because I'm shifting right 1. So 1 plus 1 is 2. And I'm going to subtract 2 from my y-coordinate since I'm shifting down 2. 0 minus 2 is -2. 2 plus 1 would give me 3. 1 minus 2 would give me -1. And then lastly, 1/2 minus, or +1, sorry, is my 1.5. And my -1 minus 2 is -3. So let's go up here and plot my points. So I'm going to go to 2, -2, so 2 down 2. I'm going to go to 3, down 1, and I'm going to go to 1.5 and down 3. And you can see my graph growing slowly upwards and then coming down along my vertical asymptote. So what happens if I do reflect my graph across the x-axis, if I reflect it down? Well, basically my points then, my y values, my points just reflect across the x-axis. So my 1, 0 won't change. It will stay on the x-axis. However, my 1/2, -1, that will reflect up to 1/2, 1. So it will be above my x-axis when it reflects up. And my 2, 1 will reflect down to 2, -1. My 1, 0 didn't change spots. So my 2, 1 reflects down to 2, -1. And when I connect my points, I basically get a reflection in my x-axis. This is what happens when I multiply my log by a negative and I reflect it down. So I want to look at some bases that aren't base 2. So the worksheet, the review sheet that your classmates are getting in class, this is the back side of that. And it has bases that are not 2. Let's look